Hi there, I'm Jane. I've been teaching sacred geometry for the last 30 years. This is my passion. I believe that shape stores memory. The language of shape and pattern recognition is a universal language, and this is an important part of the future curriculum, that every child learns about the 5 platonic solids, or what we call 3-dimensional geometry. I just wanted to explore just some different aspects of shapes. We all know the cube, but what's inside the cube? So if you were to put a dot on every face center, imagine 6 dots on the faces of this cube, and if you were a spider and you could go inside the cube and join the 6 faces with your magic golden thread, what shape would be inside? So I'll just open up the cube so you can see the answer. So if we opened up the cube, you can see that the negative space inside the cube is like a diamond. And when I say diamond, a 3-dimensional diamond is an octahedron. So here we have the fluorite crystal. It's a natural crystal. This crystal hasn't been polished. It's actually in its raw state. So you can see that the fluorite crystal fits perfectly, say, inside this cube. So that means the negative space inside is created from what we call the 6 face centers. So there is a special name in sacred geometry. It's called a dual. Dual means 2, because these 2 shapes, the cube and the octahedron, are conjugal. It means they're a pair. The word conjugal means as if you're married. So these 2 shapes are forever married, because if I did the opposite or the converse, if Magic Spider went into the octahedron of 8 triangles and said, what shape would I get if I joined the 8 centers of the faces? So the spider's inside, and it joins that dot, this dot, that dot, the 8 dots. So inside of this octahedron is a tiny little cube. So this is the solution. So that's a pair called a dual. In fact, they're called platonic solid duals. There is another shape. There's another shape here called the cube octahedron. This is not a platonic solid. Platonic means that all the faces are the same. So here we got triangles, and there's only 5 shapes that do that. Here we've got squares and triangles, and because it's mixed, it's not a regular solid. We call it semi-regular. So this shape here, the cube octahedron, was formed by slicing this shape. So if I took the cube and it was like a potato, and I said, I'm going to slice off the 8 corners like this with my knife, I would end up with this shape. And this shape is also the same as this shape here. This is the cube octahedron. Buckminster Fuller called this the jitterbug, because it would alternate its spin. And it was a shape-shifting molecule. There's the octahedron, and there's the tetrahedron. So this is all from the cube by slicing the corners. But if Magic Spider said, I'm going to go inside, Magic Spider says, I'm going to join this center, that center. There's 14 face centers, 6 squares and 8 triangles. So the shape that lives inside of this is this shape here with 12 diamonds. It has a name. It's called rhombic dodecahedron, because rhombic means a diamond, and do means 2, dec means 10. So dodec means 2 and 10 is 12. So here's 12 diamonds. So this is the shape that's inside the cube octahedron. So these are another dual, or they're married forever, because if this Magic Spider went inside of this shape and said, I'm going to connect the 12 centers of the 12 diamonds, I end up back to this shape again. So that happens with many shapes. And another pair is this shape here. Again, this is not a platonic because it's mixed. It's got triangles and pentagons. So if I had to give it a name, I would call this 3535, because at any point or vertex the numerical signature is always the same, 3, 5, 3, 5. And what's special about this shape is that if I went inside this shape and said I'm going to join with my magic thread this center, that center, that center, if I joined all these centers, I end up with another shape. And this shape is made up of 30 diamonds. And a lot of these toys, they're magnets. The children love learning sacred geometry by sort of playing with toys like this. They can study the inside and the outside. They can drop them in there, and this is the best way for children to learn. And this is also a magnet as well. Like you can see, this is like an X chromosome. It can literally drop and join. So the kids love all this stuff. So I often travel around the world with all my magnetic toys, and then the kids look at this and they say, I want to build it. So we get big broomsticks with joins, and we make bigger versions of this. So I just wanted you to appreciate that these two are a pair. They're forever a pair. The cube and the octahedron is a pair. And the other pair, as we know, is this cube octahedron is married to this shape. So I just wanted to show that there's some similarity. There's different families for different shapes. And the more we study this, the more we receive understanding about what's this language, what's it telling us, how can we build these in our homes, and what's the proportion of this axis to that axis. If this was 1, this would be 2. Or if this was 1, this would be 1.4. But we might want a shape that's in the golden ratio, so that the triangle, the diamond that's in the ratio of the pine cone is 8 to 13. So this particular diamond is more useful than, say, this diamond. So that's where mathematics comes in. If we want to do buildings that are in the geometry of, say, like the pine cone, I look at this pine cone, I can see that there's, say, 1, 2, 3, 4, 5 spirals going one way. But if I look closely, there's another 13 spirals going the other way. So when I study the mathematics of nature, 8 to 13, I realize that some of these shapes in these jewels are also in the ratio 8 to 13. So this shape has very special qualities. So if I was to build a house, a roof, based on this shape, it would have a very special benefit that would be harmonizing and calming, and also aesthetically beauty, because we want to create beauty in our life. That's why we study nature. Okay, thank you.